Alright, here we're going to look at some polynomial functions and on how to graph them. Alright, for the first thing, here's a polynomial. Remember, degree n, and then it goes down by 1, of course, to the next one, to the next one, to the next one, but the degree of the polynomial is the highest power, or n, right there. Alright, then what is the domain of all polynomials? All polynomials are always all real numbers. So all real numbers. Alright, if you look at my example here, I have this function x to the fourth minus 4x squared, so the degree of this polynomial is a 4, right? Alright, now notice how it looks. It goes down here, it curves up, it curves back down, and curves back up. So there are these turning points right here, here, and here. A turning point occurs where the graph of the polynomial function changes from increasing to decreasing, or from decreasing to increasing. So my function's decreasing, and then it increases. Then it decreases, and then it increases. So that change, or that valley, that hill right there, those are turning points. Okay? Now, a polynomial with degree n, so with degree 4, degree n, whatever this is, has at most n minus 1 turning points. So it has at most 4 minus 1, or 3 turning points. So it has at most 3 turning points. And I have 3 turning points. And at most, again, I missed a letter here, at most n x-intercepts. So at most 4 x-intercepts. Okay? So at most 4 x-intercepts. How many x-intercepts do I have? Well, I have 1, 2, 3. I have 3 x-intercepts, but I could have 4. If this went up like a little further like this, let me grab my pencil. If I drew this and went up, and then it turned maybe down there like that and came back down, then I'd have 1, 2, 3, 4. So it could have up to 4 x-intercepts. Alright, so number of turning points, we have 1, 2, 3, because it's a fourth degree. Even or odd or neither. Well, remember, symmetry is with even and odd, so it is symmetric to the y-axis, so we have an even function. Alright, local or absolute minimums. Well, the minimum is right here, and it is an absolute, and each of them are also local, so it is -4. So we have a local and absolute minimum of a -4. That's the lowest point on the graph, and there's 2 of them. Local and absolute maximums. Well, there's no absolute maximum, but there is a local, and it's right there at 0. So we have an absolute we have a local maximum of 0.